All right. Hello, everyone. Welcome back. I hope that you all had a really excellent and, I don't know, hopefully relaxing reading week break. Did anybody do anything interesting? I took my kids to some birthday parties. That was thrilling. That was really exciting. No, my reading week was extremely boring. It was really boring because it's basically just doing assessments and grading. That's my whole life. That was my whole life, the whole week. Yeah, just assessment and grading. That's all I was doing the whole time, pretty much. Related to assessment and grading, the term test it's nearly finished being graded. It's nearly finished being graded, and you should expect to get it back this week. The other thing that I was working on over the reading week break was taking a look at all of your projects. So I've now had a chance to look at every team's project in our section. And you almost certainly noticed me putting some issues in your GitLab issue trackers. So basically what I do when I'm going through your project is try to go through what I see in your projects and tell you about some of the design concerns that I have about your project. These are not meant to be like me trying to shame you. So I want to make that clear. I'm not trying to make you feel bad. I'm trying to help you be better developers and help you be better at designing software. That's my goal. I'm not trying to punish you by coming up with all these, issues that I've identified with your code. But these are issues. These are real issues that I've been able to identify with your code. And they range from things like small issues like there's mixing of concerns in different classes and different layers of your architecture. So sometimes it's a case of you're using toString in your presentation layer, and you've got domain model objects that have toString that are being used to just directly dump onto the presentation layer. That's not a good approach because we want to make sure that when we have our presentation layer, it's completely separated from our domain model. It goes to other things like, making sure that we have the right classes and the right packages and making sure that we're going to be able to build on the software going forward. The design smells that I have identified that I put issues in your tracker for, that's your top priority. So even before building new features, fixing these issues is your top priority for iteration 2. If there are design smells that are like left over from the last iteration, that's going to affect your assessment for your project negatively. So make sure that you're taking a look at those first. If there's something that you don't understand about what I have commented on, which is it's totally fair. If there's something that you don't understand that I've commented on, either contact me by email or just reply to the issue that I created, because I get emails from GitLab when people are making comments and closing and stuff. Or just come talk to me either after class or come talk to me during my office hours to get an idea of what it is that I'm looking for. And potentially what ideas I have for suggestions about how to make this better. So if there's something specific to your project that you're looking for guidance on or feedback for, come and talk to me. Come and talk to me. Let me be a resource for you to help make sure that you're able to succeed with the project that you're building. So I'm not gonna like leave that open to all questions right now because the design smells that I'm identifying are pretty project specific. So if you do have questions about that, please come let me know, or please comment on the issues that you find in your issue tracker. What we're going to be focusing on today is introduction to design patterns. And I've mentioned this idea of patterns before, design patterns before, and now we're going to be looking at these in earnest. Today, we're mostly going to be looking at motivating design patterns and looking at ways that we can think about designing software with alternative approaches to inheritance. So inheritance is something you've seen before, but we're going to look at some alternatives to that. And then this leads us into this concept of design patterns, where we're going to be able to take these reusable ideas about how to build solutions to problems and apply those to the software that we're building. So what I want to look at today is look at some limitations of inheritance and then some alternative patterns and solutions to inheritance that can accomplish some of the same things that you might use inheritance for, but doing it in a different way that doesn't have the issues that are related to inheritance. We're going to look at composition, aggregation, and delegation in a little bit of detail. We're going to look at mixins in that I'm going to tell you what mixins are, and I'm going to tell you how Java supports mixins, but then we're going to stop talking about mixins. We're not going to spend a great deal of time talking about mixins. We are then going to spend more time talking about cross-cutting concerns. So all of these are related to the idea of inheritance, and all of these are related to the idea of what you may have used inheritance for in the past. Reducing duplicated code, reducing duplicated code. Let's take a look. So Comp 2150 was basically this, and I'm living this life right now. I'm going through Comp 2150. And the topic that we're going to be doing in 2150 this week is the 9 forms of inheritance. So yes, it's beating this horse to death. Comp 2150 is basically, hey, look, there's this giant hammer that is inheritance. Let's use it for everything, please. But that's really not a good solution in general. Let's think about inheritance. Let's try to answer 2 questions that are related to inheritance. First, what is inheritance for? So like, why do we want to use this hammer in the first place? What's the goal that we're trying to accomplish by using inheritance? And then let's think about what's wrong with inheritance. What are some things that are inherently wrong with using an inheritance relationship to describe the relationship between 2 kind of classes or objects? Inheritance models an is-a relationship. So this is a key word that we want to be thinking about when we're thinking about inheritance relationships. We've got these domain model objects. They are related to each other with an extends or an inheritance relationship when you can say that one of these things is another of these things. So the canonical examples of this are like animals. You have an animal superclass. A dog is an animal. That's the way it is. It's not that a dog has an animal. A dog is an animal. A dog is an animal that has legs. A dog is an animal that has a snout. A dog is not a snouted animal. That's a kind of a weird relationship to say that you've got between these 2 things. Inheritance models this is-a relationship. One of the things that we want to model here is behaviors. So trying to share behaviors. Inheritance is used to have, like, bring down the superclasses instance variables, but we also want to be able to model behaviors. There are some language-independent approaches to modeling behaviors: composition, aggregation, and delegation. And this is what leads us into this idea of design patterns. These are going to be common solutions to solving this inappropriate use of an is-a relationship to describe 2 domain model objects. And then there's language-dependent solutions, which is this thing called mixins. Our goal ultimately here is what we want to be able to do is have a relationship between classes and between things that we have in our domain model objects that are going to have behaviors between them. So let's start by talking about composition, aggregation, and delegation. I'm going to define these terms, and then what we're going to do is look at an example of using this. Composition, aggregation, and delegation are all pretty closely related to each other. The idea for all of these is that we want to extract and model behavior from an object. We've got these domain model objects. They do similar things. We want to be able to extract that behavior into a class of its own and then use that common thing between all of those things. Ultimately, we want to extract that behavior and delegate that behavior to another class, so to another object that implements that behavior. Composition and aggregation are similar to each other. They're very similar to each other. Composition, I'm going to read this aloud to you. I don't like to read slides to people, but I'm going to read aloud this slide to you. Composition. Add behavior to a class by delegating responsibility of implementing that behavior to another class. We've got a class. We've got a class in our domain model. We want to add behavior to that class by putting another class inside of it. Embed many classes as instance variables. So we have a domain model class. We have a specific behavior that we want to add to this domain model class. We don't make it extend something else. We just add an instance variable that has this behavior for us. Aggregation is add behavior to a class by delegating responsibility of implementing that behavior to another class. Okay. And the way that we accomplish this is by embedding many classes as instance variables. That's clear? The difference is clear to everyone? I'll let you read it. I'll let you read that. We're good? Yes? Yes? Okay, ha ha ha, okay, yeah, yeah, ha ha, what's going on? Okay. I've been cooped up in my office grading all week. Give me a break. Okay. The difference between these two concepts, they're super closely related to each other. They both have the same basic general description. The difference between composition and aggregation is that composition implies ownership of instance variables. So you've got this class that you have created. You have instance variables within that class that add behavior to this class. So you've got instance variables inside of it. You have accessors and mutators to get access to those inner instance variables. When you destroy this class, so in Java, it goes out of scope and it gets garbage collected. Destruction of that class implies that all of the inner classes that are part of it are also destroyed. They are contained entirely within this class. Aggregation doesn't imply ownership. So you've got separate classes that are related to each other. One of them may have an instance variable inside of it as a reference to some other class. But destruction of that one class does not mean that the other classes that are related to it by instance members are destroyed. Let me paint a picture for you. We all go to a university. We are all at a university right now. A university is composed of faculties. So the University of Manitoba has the Faculty of Arts, it has the Faculty of Science, it has the Faculty of Engineering, it has the Faculty of, I don't know what the business school is actually called, the Asper School of Business, the Faculty of Business. We've got the Faculty of, I don't know what I've already said, Faculty of Architecture. We have different faculties. Faculties are composed of many different departments. So think of this as classes. You've got class university, public class university, and inside of university, there's a collection of faculties. Within the class faculty, you have a collection of departments. A department is, in our case, computer science. This is a composition relationship. If the University of Manitoba is destroyed, okay, so, terrible things happen. They go bankrupt, somebody bombs us, I don't know. When the university ceases to exist, the Faculty of Science also ceases to exist. When the Faculty of Science ceases to exist, the Department of Computer Science also ceases to exist. The university is composed of faculties. Faculties are composed of departments. A department has students. When the Department of Computer Science goes away, we do not go away. We are not also destroyed because the Faculty of Science is gone and the university is gone. Because it went bankrupt, we do not get destroyed. We're doing our own thing. We're maybe sitting in this classroom, but we don't go away. A department as aggregated students. The university has aggregated buildings. The university goes bankrupt. The buildings that are on this campus do not go away. So there may be a collection of buildings within this university class, but the buildings do not go away when the university ceases to exist. They are still here. Is that okay? We're good? Good. So the difference between aggregation and composition is entirely about ownership of the related class and whether it gets destroyed when the owning thing gets destroyed. Here's an example. This is our very first example. This is, I gave this out as a piece of paper. I've got a couple more copies of this if you need one. This is also on the course webpage, so you can find this. It's called Bad Code, ? This is an example of a class that currently uses an inheritance relationship. So the class is called counting list, and it extends array list. We can assume that this is some kind of a list. I'm going to give you a few minutes to talk with your team about whether or not there is a bug in this code that is related to the relationship that we have modeled this as right now. And then as a second step, so I want to do this in 2 steps. I really just want to look at is there a bug in this code? And then we'll secondly think about how to use composition to think about this. So I'm going to put, I don't know, 3 or so minutes on my timer. And your job right now is just, is there a bug in this code? There's a bug in this code. There's a bug in this code. What's the bug? What is the bug? Okay? Go ahead. Okay. So I popped this up. Let's take a look at our class here. Our class is called counting list. It extends array list. We're overriding 2 methods here. We're overriding add and we're overriding add all. Some people are pointing out, okay, well, add all is taking this type of collection instead of array list. That's actually okay. This is okay because the superclass array list defines the method this way. And in fact, the superclass of array list defines the method this way. The superclass of array list is abstract list here. And then these classes are all implementing these interfaces collection list. So those are defined higher up in the hierarchy. And that's okay. That's actually okay because it means that we should be able to just take any instance of collection and add all of its content to this thing. I'm gonna tell you what the bug is. I'm gonna tell you what the bug is. If you got it, great, excellent. The bug is that because we have extended array list, we get all of these methods. All of them. Because we have array list as our extension, we get all of these methods. And some people say, okay, we could just use size, because size is definitely part of array list. Yeah, that's a bad design. It's a bad design for this class. I shouldn't use this in the first place, but I did anyway. The bug here is that we get all of these methods, and I didn't override one of them. I didn't replace it. So if somebody were to use my class and use this add, insert at a specific spot in the list, it's not going to count it. It's not going to count it because I have given them access to that method in the inheritance relationship of extending array list, but I haven't overridden that method. I do get all of this for free, but I also get all of this. And I have to be responsible, me as the dev maintaining this class, this counting list class, I have to make sure that anything that's exposed by my superclass, I'm either accounting for by overriding that behavior and making sure that I'm keeping track of all the data that I want, or doing something else. Now I'd like you to do the second part here. I don't want this to be an is-a relationship anymore. A counting list is a list. It's a list, I guess, but I don't want it to be an array list. I don't want it to extend anything anymore. I want this to be a class that doesn't extend anything. So my task for you right now is to take just a few minutes. You're more than welcome to write this down on the paper. You're more than welcome to type this up if you want, but really I'm looking for you to just discuss this with your team. How would you change this class to use composition instead of an inheritance relationship? What would you do to accomplish that? So take 5 minutes. I'll step through what I would do for this in about 5 minutes, and then we'll all get back together. All right. So here's my code. This is the counting list. Right now, as this is, the relationship that we have between counting list and array list is an is-a relationship. But we want to turn this, our goal is to turn this into a has-a relationship. So composition, counting list, our goal is to turn this into composition where we've got a has-a relationship as opposed to an is-a relationship. The first change that I would make to this is to not extend array list anymore. One of the things that I am accomplishing by doing this is I am taking control of the interface that's exposed by this class. I can't just plunk this into any list interface anymore. I can't just use this anywhere that I would use a list, but I've also taken control of that interface. If I give this code to somebody else, they can only call those 2 methods on this thing. They can't call other methods that I do not control anymore. The other thing that I'm going to do here is I'm going to make an instance variable. When I'm doing this, I'm going to put array list here. And then rather than super.add and super.addAll, I'm going to say list.add and list.addAll. One of the things that I'm losing with this is that, well, in the state that it's in right now, I can't remove anything from this list, but maybe that's okay. But I don't have a bug in this anymore. I don't have that bug. Again, it might be badly designed, but I don't have that bug of unintentionally getting all of those methods through that inheritance relationship, through that is-a relationship. While I'm here, I wanted to make a note about, it kind of brings up something that I commented on a lot of people's projects. One thing I saw a number of times over was people putting projects having code that looks kind of like this, where they've got public array list, something, get somethings, and then returning an instance of an array list from within that class. Generally, what you want to do when you're looking at these things is to return the type that best describes it, the interface that best describes what you're trying to give back, so you're not exposing internal implementation details of the class that you have. So by returning an array list here, what I'm telling the caller is that they should expect an array list to come back, but I don't really want them to know that I'm using an array list internally. Instead, what I would want to do is return a list. So use the interface type that best describes what my goal is for this data that's contained within it. So list is a type that specifies order. So this is the interface for a collection that says there's a first element and a second element and a 0th element and whatever. Another option is to use something like set. The set interface doesn't specify order, but it does specify uniqueness. You can only add an element once to that list, provided that the hash code or the equals methods return different values. And if you just want to say that you're going to give back a bag of data, here are all of these values that satisfy this thing that you're trying to do, but they're not ordered. They're not necessarily ordered, and you shouldn't expect them to be ordered. Return a collection instead. So the general advice here is try to return the interface for the kind of data that you want to give back, as opposed to giving back the specific implementation that you're using internally in the class. Okay, so I've now converted this is a relationship into a has a relationship. We okay with this? We're good? Good, good, good. Okay. All right. So composition and aggregation are ways to delegate responsibility and behavior to other classes to give you the same kinds of things that you would get with inheritance without inheriting from something. The benefits of composition and aggregation over inheritance is that we can control the interface for the thing that we're building up, and we don't get all of the extra baggage that comes from that inheritance relationship. We don't have to care about everything that the list interface specifies. The drawback of that is we can't just use this code in place for implementations of list. We can't just use this class in place of implementations of things that accepted array list, for example. If we want to do that, we would want to say that this implements something like list t as opposed to extends array list, and then we'd have to implement all of those methods ourselves. So we get to control the interface a little bit more. So composition and aggregation are using delegation. Mixins is another way to add behavior to a class without using an inheritance relationship. The idea here is that we can have a class that has methods, and that class with methods can be injected into the other class. This is a kind of a language-specific thing. The idea is that we get the behavior of something that looks like a parent class without saying that it has this is a relationship with that class. So an idea here is, I'm going to take a look at the list of languages that support mixins, which is a bunch of languages that up until a few years ago did not include Java. I know Java 8 seems old at this point, but they really accelerated version numbers in the last little while. Java 8 is still fairly new compared to other versions of languages. And this is probably a website that we've all seen before. I know that when I'm trying to find out stuff about Java, that this Beldung website comes up almost always at the top. So whoever the author of this website is, they've got their search engine optimization game top-notch. Like, good work for this person. One of the things that Java recently added was this idea of a default method on an interface. So way back in Comp 2150, you learned about interfaces. And with interfaces, what you are specifying is just the list of methods that a class that implements this interface must have. So you've got this, it implements this thing, and then a bunch of methods that the class that implements it has to be able to do. A new feature of Java is that you can have default methods on an interface. A default method on an interface is a method that can't refer to instance variables because it's an interface. But when you implement the interface, the default method is what you can get. So you can define some behavior in this default method for this interface. You can write your class so that it implements that interface, and then you get that default behavior without having to implement that method yourself. This is different from abstract classes that have methods in them. in that a default method in an interface cannot refer to instance variables because it's not an instance of anything. An interface is just an interface. It can refer to other methods in the interface, but it cannot refer to instance variables. With this, because you can implement multiple interfaces in Java, you sort of get multiple inheritance. Sort of. You can have default methods on an interface. Multiple interfaces can be implemented by a class, and they may collide with names like this. Java's approach to solving this multiple inheritance problem is that if there are multiple interfaces that have default methods, you have to provide your own implementation of that method. You don't just get to get one from the implementing interface. So a mixin here, the idea is we've got this definition of behavior. Here's a bundle of behavior. This thing can do this. So this is more of a can-do relationship than a has-a or an is-a relationship. Something that implements this interface can do this. Here's a default implementation of that, so I don't have to write it myself, and I can just bring it into my class. I can inject it into my class by implementing this interface. This is really language specific, though. This is the way that Java does it. Ruby does it in a different way. JavaScript does it in a different way. Dart does it in a different way. All languages that support this will do this in a different way. It's not really something that is like a thing that goes across languages. End of conversation about mixins. We're not going to talk about this anymore. I'm not really expecting you to use it in any way. Just know that it's there as a way to have an alternative to inheritance relationships. All right, so let's move on here. Let's talk about cross-cutting concerns. So one of the things that we've been looking at with inheritance relationships is that we've got this is-a and has-a relationship. And one of the goals or one of the side effects of using these approaches of inheritance or composition or delegation or aggregation is that we're able to duplicate behavior across classes or across implementations, or add behavior or change behavior of our classes. Sometimes, though, we have functionality that we want to run before all methods in a class, or after all methods in a class, or during the execution of methods in a class, but not in any way that can fit into this whole is-a or has-a relationship. We just blindly want all methods in a class to be able to have something that happens before them. The functionality that we want to implement applies to basically all actions, methods, or even across classes that we have in our code base. We want to take this functionality and we want to apply it to a bunch of different things. The classes that we want to add this functionality to are not in any way related to each other and should not in any way be related to each other. We're going to look at an example of what this functionality is and what the broad set of classes is that we want to do. And that is in the form of example 2. So that's on the back of this page. And that is on the course web page, is the second page of this document. I will pop this up on my screen. Here is the goal. Let me open this code up rather than just hand waving. That is not helpful. I'm going to open that up in VS Code so that it doesn't underline everything. There's another class beneath this, but what I'm going to do is scroll down like this a little bit, and we can see that there are methods that are similar to each other. Our goal with this example is that we have persistence classes. you all have projects now that have persistence classes in them. They may even be HSQLDB classes, maybe. They will be soon if they're not yet. The goal that we have with this code sample is that we want to make sure that before any changes to our database are made, that we have a valid user account that's logged into our system so that it's been validated and approved or whatever. We don't want changes to our database to happen by users that have not been logged in. We don't want to permit that to happen in the first place. So we've got a code sample here. The comment, change address, change name, those things are going to be, let's actually do that thing in the database. My questions to you are, is there anything wrong with the way that this looks right now? And if there is something wrong, there is something wrong. There's something wrong. Okay, what's wrong with it? So I'm going to leave this code up. I'm going to give you time to look at this. I'm going to give you time to think about it. What might you do to solve this problem? What could you do to solve this problem? Should these classes be related to each other in any way? Because we all want to do the same thing in all of them. Should they be related to each other in any way? Please go ahead. Yes. Yeah. Okay, good. You're in the right spot. All right. So I'm going to start. What I'm going to do is use some words that I've heard a bunch of times now. Duplicated. Repeated. Yeah. That's it. Those are the two words that I heard. Those are the best words to describe the situation. Duplicated and repeated. In every one of these, so we have student persistence and we have beverage persistence, HSQLDB. These classes, they are related to each other in that they have the suffix HSQLDB, which implies that they are SQL classes. They take our data model and they transform it into SQL for persistence purposes. Student and beverage, though, are outside of these two classes, maybe belong in the same package in our architectural packages. There's no clear relationship between beverage and student. There is no clear relationship between them. The methods that we've got here, change name, change address, change quantity, and change location, they're not related to each other. Even within the same class, these methods are not related to each other in any way, beyond that they apply to maybe the same domain model classes. The tools that you have right now, the same thing to do is, well, this is all duplicated. Every method that we have has these same 5 lines of code. It has these same 5 lines of code. They all have the same 5 lines of code. So let's do something like this. Public class, I'm going to say final class. You can't extend it. HSQLDB utils. And then I'm going to say public static void authorized. And then I'm going to put those 5 lines of code inside this method. And you can then go through the process of HSQLDB utils dot authorized, and then copy and paste that into every one of these methods. That is a reasonable solution, is totally a reasonable solution. But the problem with this, the main problem with this is, well, maybe I also want to add a new method to this. So public void find beverage by type. And I'm a good programmer. I think I'm a good programmer. I'd like to think I'm a good programmer. I'm going to say final beverage type T. I'm going to have this return a collection of beverage. And I'm going to say, OK, find and return beverages. I wrote my query, and I have a return statement. But oh no, I forgot to check that this person is logged in. I forgot to do that. I added methods to this other class, and oh, I forgot to check. So now everybody can just see everybody else's transcripts. A good idea outside of this, using a static method, was to raise this functionality up to your logic layer. So the logic layer is the only one that's calling the persistence layer. So move this up into the logic layer. And that actually makes sense. That's a good approach to solving this problem. But it suffers the same problem. I forgot to add this check to see if somebody's actually logged into the system before I started. These are good approaches, but you don't have the tools. These are cross-cutting concerns. So I'm going to go back to this statement here of what this is that we're looking at. This idea of checking that a user is logged in across all methods in our classes, regardless of their type, is a cross-cutting concern. It's not something that we have an is-a relationship. It's not something that we have a has-a relationship or can-do relationship. This behavior applies to all methods, even if they are unrelated to each other. The solution here, oh, I don't want to do that. I'm going to do the solution, then I'm going to come back to this, because I do want you to actually think about this. The solution here is to go about using something called aspect-oriented programming. So we've been living in this object-oriented world for a long time. There's another paradigm of programming that's called aspect-oriented programming. Aspects add behavior and modify functionality of code without modifying the code. So this approach that we have here, we are intentionally and explicitly writing this behavior of check to see if somebody is logged in. We have modified this code to add that behavior. Aspect-oriented programming gives us the ability to write code that modifies other code without changing that code itself, without making those changes in place. The way that we do that is we define this thing called a PointCut. A PointCut is kind of like a regular expression. Do you all know what regular expressions are? Please put your hand up if you don't know what a regular expression is. It's okay if you don't. Okay, a regular expression is a way that you can describe text. So you can describe the way that text looks. It has to be an A followed by a B followed by a C. Or it has to be any number of A's followed by exactly 10 B's, something like that. It's a way for you to describe what that looks like. A PointCut is a way for you to describe what a class looks like. It's a way for you to describe what a method looks like. Methods that have this return type, or methods that belong in this class. All methods that are in this class, or in some place that you have seen something like this before, all methods that have @test as an annotation on them. So like JUnit tests. JUnit tests are using annotations to support this PointCut idea. All methods in a class that have @test on top of them are tests. They are tests, and they should be invoked by the test runner. A PointCut is a way for us to describe what a class looks like or what methods look like that we want to add behavior to. Here's an example. A PointCut here says, when we want to do it, so before the method that matches this signature runs, I want to do this. The PointCut here says any method that has a name that starts with the word change, and then it can end with anything, and it can have any arguments or parameters. This is the code that you should run. So this join point static part.get signature, this is going to be part of the library that you'd actually use to do this. But the idea here is that you could take this authorized method and dump that into this PointCut. And then this block of code is going to be run before any method that has the name change. Regardless of what class it's in, regardless of what else it's named, if it starts with the word change, it's going to have this code invoked. After says after this code is executed, so we've returned from the method that matches change star with any parameters, I want to run this block of code. So we're making changes to existing code. We're making changes to the behavior of existing code without actually changing the code itself. Because I'm using patterns like this, I'm describing what this class looks like. And this can be things like anything that has this package name, anything that has this package name. So all classes within this package, or all methods that are within classes that are within this package. We're able to describe what code we want to add behavior to without having relationships between those classes. Here's what I'd like you to do with your team is just spend about 5 minutes, and I'd like to get some feedback from you about this. So spend about 5 minutes thinking about other kinds of things that you could be doing in this sort of setup. We've got checking that a user is authenticated, checking that somebody is logged in. What other kinds of things might you want to add or enforce across all methods in a class or set of classes where there's no relationship between them? Please go ahead. Take 5 minutes. We'll get an idea of what this looks like. All right. So what I'm going to do here is I've got a couple minutes left. And I'm going to put people on the spot, but I want to be clear that there's no shame if you just have no, we don't know. This is a completely new approach to programming, so it's okay. And I will just give you some examples of my own afterwards, but I want to get a sense of what kinds of things I'm thinking about here. So I'm going to generate some random numbers, and team, I guess number 1 is randomly the first one that shows up. You have ideas. What kind of things might you be able to do with this, or might you want to do with this? Okay, that's good. Number 5. Okay. Yeah. Okay, good. That's great. And that's actually one thing that we didn't talk about this. All of these methods end with leaving the name of method that we're doing. So all of these methods have that same print statement, leaving this thing. These are log statements. Another team was talking about with this. An example of the use of this might be you have production, your user has come and said, hey, there's a bug, but nothing crashed. It's just a bug in the way that this works. This is when I saw that bug. This is the time that I saw that bug. One thing you can do with this is start tracking, well, when did this method get called? When did it leave? And what was the state of certain things? Like who was logged in? So you try to see the path of the user through the code that you were using. So that's great. Thank you, Team 5. 8. Does Team 8 have any ideas? Okay, that's actually a great example. So, it can be something that says, I want to match methods, I want to match methods. So it's a star. I want to match all methods, and I want to match all arguments. All in this method are default. So we don't have this code here, but we can ask questions like, what is the value of all of the arguments that this throw a null pointer exception? I don't even want you to call this with null. I'm just going to forbid it by throwing an exception before it starts executing. You could accomplish painful memory. object is preconditions, postconditions, and invariant. Preconditions are, let's make sure that the things being passed to us are not null. We have these that we're setting to our caller. The state of our, we could use these ideas of before and after to apply that. We have an object that will return invariant interface.